Now next, let's see how to rationalize the part of irrational numbers. So the concept here is rationalizing the irrational numbers. Part of. Let's see how this can be done out there. So for example, I have a number 3 by root 12 and I would like to rationalize this denominator because my denominator is an irrational number which I would like to rationalize. So in order that I rationalize, I understand that its root has to be removed. Rationalizing the root is possible only when the root vanishes. Therefore, in order that root 12 has to vanish, let's try to see how this is possible. It's very simple because when you have the number 3 by root 12, I can simply rationalize the denominator by multiplying and dividing the same rational number besides the given number. So here is the root 12, so I multiply and equally divide so that it doesn't disturb the justification of the mathematical value out there. So once the root 12 is multiplied and divided, I get this to be 3 times root 12, which is 3 root 12, and root 12 times root 12 is already known with the property root x times root x is root x whole square, which is x, and therefore root 12 times root 12 must be 12, and therefore this can be simplified as 3 1s 3 4s root 12 by 4. This can also be further simplified by taking root 12, which is 4 times 3 and by 4, so that this can be split as root 4 times root 3 by 4, because root AB is root A times root B. Every factor can be split in the root provided it is in multiplication. Root of A plus B is not equal to root A plus root B. The splitting of roots is possible only in division and multiplication. So I have root 4, which is 2 times this by 4, which can be further simplified as 2 once and twice, so that the final answer is root 3 over 2. So interestingly, the irrational number which was in the denominator jumps to the numerator. So we have now an irrational number in the numerator, but there is no irrational number in the denominator. This is how we rationalize through either the numerator or the denominator, depending on the question given. Rationalizing the numerator and the denominator is very much possible, as witnessed with this example problem. Let's see one more example through which we understand the rationalizing concept of an irrational number more better and more stronger. For example, I have my x, which is 1 by root 11 minus root 9, or I have this 2 by root 11 minus root 9, and I clearly see that the denominator has irrational numbers and the numerator has strictly a rational number. So my question out here is, how do we rationalize the denominator, which is irrational presently? So let's see how we can rationalize the denominator out here. So in order that I rationalize this denominator, the concept in case of two added or subtracted numbers is that I multiply and divide the same number with opposite sign in between. That is, when I have 2 by root 11 minus root 9, then I multiply and divide with the same irrational numbers but with opposite sign. If I have minus out here in the given question, I have plus, which I multiply and divide. If I have plus in the given question, I put the opposite sign minus in the numerator and denominator. Is how we understand the general rule which applies for any problem where the denominator or numerator is rationalized in this format. So I multiply and divide with this, which gives me 2 times of root 11 plus root 9 by root 11 minus root 9 times root 11 plus root 9 is how we get it. Now clearly I see here that this is root 11 plus root 9 by, this is clearly in the form a minus b into a plus b, which we know through the formula that a minus b times a plus b is a square minus b square. And therefore, this minus this into this plus this is a square minus b square. And finally, this comes out to be 2 times root 11 plus root 9 by square and root both get cancelled, and I get this to be 11 minus 9. And therefore, this comes out to be 2 times root 11 plus root 9, of course, is 3. Though given in the question in unsimplified form, I can substitute this root 9 to be a perfect square to be 3, and 11 minus 9 is 2. Therefore, I see that the denominator is rationalized finally. The denominator which was in roots is no more with any root form. And further, I can simplify this to bring into the more simplified form so that I get my x as root 11 plus 3 is how we get for this. And thus, we finally understand that denominator is finally rationalized. Rationalizing the denominator or the numerator for any given number is possible. Exponents connected with real numbers. Now that we have seen different properties like rationalizing using a plus b into a minus b, which is a square minus b square, and various other properties, now we are going to enter into connecting the real numbers with exponent properties. Laws of exponents, laws of indices is what we are going to talk about. Laws of exponents in real numbers. So let's see how they are collaborated or interconnected with each other. Without the use of laws of exponents, we cannot proceed further by operating the real numbers, is how we understand this session being important and to be learnt in the number system, in the topic of number system. Now we know that the laws of indices are a power m times a power n is a power m plus n, the most famous law of index which you have learnt in the lower classes. Similarly, the next law of index is a power m by a power n, which is a power m minus n. This is how we understand this. So based on these two properties, let's see how we can simplify some different examples where real numbers are given in this form. For example, I have a question which says simplify the real numbers which are expressed in the form 5th root of 7 cube root of 7 into root 49. So let's see how we can simplify this strictly using the laws of exponents. Now clearly I see that this can be simplified initially by extracting the roots. So because it's in the 5th root of 7, we understand that nth root of a is a power 1 by n, and hence 5th root of 7 is 7 power 1 by 5, and root 49, which is 7 because root of 7 square, and cube root of 7 is 7 power 1 by 3. So basically, when we discuss about laws of exponents, we think of making all the bases equal is the rule we need to identify. So because the given question has different bases, my first target was to make all the bases 7 equal. Now I clearly see that this satisfies the property number 2, that is a power m by a power n is a power m minus n. So replacing a by 7, I get the second law of index, which is a power m minus n, is how we understand this. Times 7, never to be forgotten. And here I get this by further simplifying through LCM. I get 7 power 15, 3 minus 5 times of 7. So I get this to be 7 power this times 7, which on further simplification gives 7 power negative 2 over 15 times 7, which can be written as 7 power 1. 3 minus 5 is minus 2 over 15 times 7 power 1. Now clearly I see this with index number 1, which is a power m times a power n is a power m plus n. Therefore this times this gives me 7 power minus 2 times 15 plus 1. When the two bases are equal, the powers are added in the product, which on further simplification gives minus 2 plus 15, which on further simplification gives 13 over 15. And therefore my complete simplified process of this problem is 7 power 13 by 15, or this can also be written as 15th root of 7 power 13. So simplifying the given problem is based on the laws of exponents if the problem gives the real numbers expressed in exponent form. Laws of exponents connected with real numbers.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.